Water is the foundation, the source, and the mechanisms that govern life, but also govern the whole biosystem and the climate of the blue planet.
Our groundwater is a treasure. It's a miracle. Somehow it's a miracle.
I spend more than $1 million every year on electricity to pump water.
Vi har aldrig påverkat planeten så fundamentalt som vi gör nu. Klimatet, vatten, mark, biodiversitet, haven.
The cycle of water and being able to understand that is one of the most critical questions that we have to deal with today in a changing climate.
It is dangerous hydrological climate extremes that are going to be threatening a whole lot of different ecological and human values.
Eventually we cook ourselves as this frog in warm water. It cooks before it realizes that the water is so hot that it is going to die.
So we really have it in our hands now to understand so that we can sustain the health of the human population.
Water is the foundation of all life as we know it. But it's the most wasted natural resource, reflecting man's intense and short time on Earth. Water is life. We measure it in drinking water, but it's much more than that. Water must be present in all of the planet's systems for it to be in balance.
Vatten kan man ofta beskriva som jordens blodomlopp. Det rör sig genom landskapet. Det tillhandahåller all näring till naturen och alla våra växter. Och vatten är grunden för allt mänskligt liv också, alla våra samhällen. Så vatten är helt central del av planeten jorden helt enkelt.
The water must be present in order for life to take place, in order for cooling effect to happen, in order for you to drink, in order for you to eat, in order for you to live in a territory that has bearable temperature and a local climate.
If we manage the water as we do now, where we use it, pollute it, and then try to dispose of it with very serious consequences, that system is not sustainable. Under that current system of water use, we are running out of water.
We are losing more and more useful water. And the association between the imbalance of the water cycle and climate-related problems is bigger than what most people are aware of. We are also not taking care of our most important substance. We just regard it as any liquid. Still, water is the very foundation of life itself.
Vattnet bildades till stor del samtidigt som planeten bildades. I grunden är vatten en kemisk förening med 2 väteatomer och en syreatom, H2O. Just den här väldigt enkla föreningen har väldigt speciella egenskaper.
Water is one of the universe's most unique materials. It has completely unexpected, unique properties.
We have it as vapor. We have it as liquid water running down rivers and in lakes and in the oceans. We have it as snow and ice in its coldest phase.
There is a sense of reverence for the water that created the diversity we see today. That during 4 billion years built a hospitable planet and the welfare we enjoy. Water that has been drunk and made of use by all animals and plants, and that has created equilibrium in the systems.
Water in its very nature comes and goes. It moves within the cycles in the nature, and this is the very basis for all the chemical reactions for happen. Our life on the planet Earth is based on the chemical reactions, but these will not take place without the water.
"97% of the planet's water is saline and is found in the oceans. The remaining 3% is freshwater, of which more than half is contained in glaciers. Only about 1% is available to us. Nevertheless, we act as if water is an endless resource."
Vatten är en ändlig resurs eftersom vi lever på en planet. Och det gör ju att vi kan inte få mera vatten någon annanstans ifrån. Däremot så är vatten så fantastiskt att det cirkulerar i systemet. Och det gör att vi kallar den en förnybar resurs.
Vi har inte behövt tänka så mycket på det. Det har alltid funnits. På andra ställen i världen är det annorlunda. Då får man verkligen kämpa för att få vatten. Men vi börjar få känna på det mer nu. Olika delar av landet som har haft torka och grundvatten som sinar.
Water is something that we all take for granted until it's not there. We just take it for granted. No matter you go, we're going to turn the tap in a hotel room or another city that there's going to be water there. I saw a study that the majority of the people in the state don't know where their water comes from. They just know the water bill when it comes.
We measure fresh water in human consumption. Human societies err in taking without giving back. We may think that the services of the planet's ecosystem are free, but everything has a price.
As humanity, when we try to manage water and we try to manage everything, and somehow it happens that we get disconnected from the nature, we don't understand it anymore, and we are actually breaking the natural laws and cycles without realizing it.
We don't value these ecological processes anywhere near enough. We just take for granted that nature will provide these and sustain them. But when we understand how profoundly we have impacted them and the consequence of those impacts in disturbing heat balances, hydrology, for example, we are very, very amiss at ignoring them.
We don't understand to value the water, nor that the hydrosphere is crucial for the ecosystems that we depend on. And the magic in that everything is created in the meeting between sun and water.
Det som är mest makalöst är ju att solenergin renar havsvattnet till sötvatten, och det är det som gör att vi har vatten överhuvudtaget. Alltså vattnets kretslopp. Det innebär att vatten hela tiden renas av naturen och vi får nytt rent vatten. Så regnvatten är väldigt rent. Sen kan regnvatten tyvärr innehålla en del kemikalier som löses i vattnet i atmosfären.
The amount of fresh water on the planet depends effectively on evaporation and transpiration. Because, see, as water evaporates, it leaves behind all the salts and the pollutants that may be in the oceans or where it's from, and it just goes up as water vapor, pure water vapor. And so it regenerates fresh water.
Vid en viss nivå, vid en viss temperatur, så kondenserar vattenångan då till vattendroppar eller vanligare faktiskt ispartiklar, snöflingor. Och de här bildar då moln, och när molnen blir tillräckligt tunga, lite överförenklat, så börjar ju nederbörd falla tillbaks till marken.
Precipitation, rain and snow that falls locally in large to no volumes at all. For water molecules to form drops, it's been discovered that aerosols are needed. Small ice and salt crystals, which are the starting point for condensation.
1 million of these cloud microdroplets need to be coalesced into each raindrop for it to be heavy enough and large enough to fall out of the air under gravity back to the land. And so this nucleation of these water droplets is a key balancing process in nature in driving rainfall.
But there are other aerosols that are important for creating raindrops. Bacteria. Through the evaporation of trees, specific bacteria end up in the atmosphere where they bind water vapor and create drops. The bacteria return to Earth with the rain that they themselves created.
And so we've had this paradigm forever that trees or vegetation needs rain. But now we have this balancing concept that rain needs trees, and that vegetation and rainfall are actually a symbiotic duality, a marriage.
We have precipitation that comes down onto the surface of Earth. That either goes into the oceans or it goes onto the land. If it goes onto the land, then some of it percolates down into the ground, some of it evaporates back into the atmosphere, some of it goes into the plants, some of it runs down the hill right away. If it falls as snow, then the beauty of that is that it stays as a mountain reservoir of water, and it doesn't move out of its system very quickly. So there's just this constant exchange of water moving across the surface, under the surface, into the atmosphere, and then back down onto the surface.
The fresh water circulates in a cycle, one that includes the seas and the desalination process. Another, where the water circulates in a smaller geographical area, evaporates, and then returns. One might think this a stable and unsusceptible system. But the human activities that impact and change the water cycle are alarming.
How it is communicated between these different phases is really what's critical for us as human beings, as well as the ecosystems that support us and that we interact with. And being able to understand that cycle around the globe, how it's changing, and how that's going to affect our fresh water supply, for us is one of the most critical questions that we have to deal with today in a changing climate.
The cycle that provides the planet with fresh water used to be in balance between surface water, soil, and groundwater, water in the atmosphere, and on land. But it is now disturbed. The water available in the biosphere is decreasing, and groundwater levels are dropping in large parts of the world.
When the rain falls down and it becomes groundwater and it goes slowly to deeper, then it takes up minerals. Here in Brabant, we have groundwater at about 80 meters deep and about 200 meters deep. It's coming from Belgium, And it travels with a speed of about 20 meters per year, so it's very slowly. And it took about 10,000 years to come from Belgium to here. We use it for drinking water and to irrigate our crops.
It is also known as fossil water. Depending on the bedrock, age may vary, but most groundwater reservoirs are ancient and were created long before humanity appeared on Earth. It's formed by rainfall that dissolves minerals and nutrients. It is the best and purest of all water, and the most important water resource for us and the ecosystems.
If you pump groundwater, and in every year you're using that groundwater without it being replenished, then the groundwater is going to decrease. Well, how far can it go?
You know how much water we pump here? 2 billion with a B gallons a year. I spend more than $1 million every year on electricity to pump water.
It's the land of the big acreages, and Fram farmland grows animal feed, such as corn and grain, on 14,000 hectares. These cultivations are possible thanks to one of the world's largest systems of fossil groundwater being available. Ogallala Aquifer supplies 8 states and about 2.5 million inhabitants with water. But the levels are dropping.
Unfortunately, we've pumped in this area at least 30% of the aquifer, say dry, or we've lowered it. And as we do that, the well is more pressed to give up the water. I mean, there's a lot of wells that only pump half of what they did when they were first developed.
Det där vattnet kanske räcker 50 år, 70 år, men sen är det slut. Sen finns det inte mer vatten. Överutnyttjande av grundvatten, det har vi över hela världen tyvärr.
Large-scale operation and monoculture costs water. It's not only the farms in Kansas that consume. About 70% of the planet's fresh water goes to cultivation and food production. Do the large-scale monocultures drain the groundwater systems to dangerously low levels?
Will the Ogallala Aquifer ever be drained? It is being drained right now. I've heard people use the word mined because it's something that's taken out of the ground and not put back, as if we were mining gold or pumping oil. It's a mining operation.
Thousands of years were required to create these groundwater supplies. And so pumping those out of there in order to get back to the same aquifer level that we had before we started pumping them, it's going to take a long time.
And so this creates enormous problems in the next couple of decades because the agriculture that depends on that water is designed to collapse.
We extract more than what is replenished. We're draining the world's most important water resources. But there is another very important water existing in environments that we hardly think of: the soil water. A hidden resource found in the soil, which is essential for life in the biosphere.
The Earth's soil, which cover that 29% or 13 billion hectares of land surface, are really a big sponge. And depending on the quality of that sponge, they can hold up to 50% of their volume in water.
Significant amount of water is actually stored within the soil sponge and as a groundwater. And as a matter of fact, it is more than the water that we just see in the form of rivers and lakes.
In order for soil and cultivated land to function and supply water, it must be healthy and alive. Microorganisms and organic matter preserve water. And in a time when rainfall is unpredictable, this is extremely important.
The critical thing is that what happens to every raindrop that falls on this Earth's surface? Does it infiltrate and get retained in a form and location where it's available for plant growth? Or does it run off, erode soils and biosystems, and then get lost into the ocean? And the difference whether it infiltrates or runs off depends on the Earth's soil carbon sponge. Whether that sponge can have the porosity and the permeability to absorb that water and then feed it into the deeper soil horizons, which are our in-soil reservoirs, because it's that water that governs life in the biosystem.
The industrial form of farming does deform the ability of soil to soak water. It just loses the humus, and you have very compact soil on top of that, which is dry. Let's say you have a heavy rain or any form of precipitation, it just slips on the surface because the soil becomes hydrophobic. So the soil sponge is leaving us, the groundwater recharge is leaving us because of that. So we're just flushing the vital component of life away from ourselves.
It comes down to impoverished soil that has lost its capacity to infiltrate and its ability to hold water. At the same time, we drain and divert the water from its natural cycle. We urbanize the planet through industrial development, and the soil horizon that was an important water reservoir is being sealed under concrete and infrastructure.
När städerna växer så hårdgör vi ytor, vi asfalterar jordarna. Vi isolerar jordarna från det hydrologiska kretsloppet, från vattnet som faller. Vi dränerar bort och leder bort vatten, det vi kallar för dagvatten. Leder bort det till floder, till sjöar, ofta ganska förorenat dessutom.
Vattnet som kommer då ofta i form av ganska kraftiga skyfall har inte någonstans att ta vägen, utan det rinner mer eller mindre direkt ut i havet till mer eller mindre då ingen nytta. Det får liksom ingen möjlighet att fylla på grundvatten och vara en tillgång.
And if we drain the water, we decrease the wetland, we decrease the biodiversity, we decrease the water infiltration, so we decrease the water cycle.
We consume groundwater and create hydrophobic soils. We isolate the soil under hardened lands, and the precipitation is diverted. This means less water on the continents and declining groundwater systems. And the consequences of this are extensive.
Dehydration is the long-term process of less and less water reaching the groundwater. That makes that, for instance, trees and other plants can't reach the groundwater anymore.
And the impact to it is actually quite horrific, because eventually we cook ourselves as this frog in warm water. You know, it cooks before it realizes that the water is so hot that it is going to die. With every drop that we flush away, less water is coming in. And this is how the desertification comes in slowly but surely.
different regions are experiencing already significant aridification, losing 20 to 30% of their rainfall and risk turning more and more into deserts.
It comes in gradually and very slowly. And people realize that there's a problem only when there is drinking water missing. But drinking water is a very small portion of the water there is completely missing within the ecosystems.
Vi ser ju vatten som en naturresurs som vi ska använda. Men vatten är ju också en förutsättning för hela naturen, för alla ekosystem. Och från ekosystemen så får vi också oändligt många tjänster. De är lika mycket grunden för liv som vattenresurser är grunden för liv. Om vi inte tillåter vatten att också vara en del av naturen så kommer vi inte få de tjänster som faktiskt behövs.
When nature withers from thirst, it gets warmer. More solar energy and neither water nor vegetation can help the cooling of the soil. Our consumption and use of the water resources thus have a direct impact on global temperatures and our climate.
It is water that, in a sense, governs 95% of the heat dynamics of the blue planet. And for the last 4 billion years, it is water that has actually regulated the climate. It's the different water processes that govern these dynamics.
Let's say that the water would be an agent which does help with the transportation of the energy. And in fact, it can both cool and heat the planet and can help to transform the energy in between various places. When we have the area which is well saturated with water and you get a daily solar input, a large amount of energy is absorbed in the change of state from the liquidus form into gaseous form.
Och den energin tas någonstans ifrån runt om för att få till den här omvandlingen. Och man får en avkylningseffekt på grund av det här vid markytan. Hela den här processen modererar temperatur i atmosfären och energibalans. Så det är en viktig spelare i hur klimatet utvecklas.
For nature, climate control is nothing new. It has endured imbalances before and created systems with water as a crucial actor. The transpiration of plants and the conservation of liquid into steam is nature's own air conditioning. But increasing temperatures decrease the amount of water on land.
När det blir varmare så ökar avdunstningen av vatten. Mer vattenånga upp i atmosfären. Och eftersom vattenångan då är en så pass viktig växthusgas så leder ju det här till att vi får en förstärkt växthuseffekt.
The water has been completely omitted from the equation when doing the math and physics in terms of the greenhouse effects, despite its crucial role as a vital agent in this equation.
Vad vi har sett i vår forskning det är att det inte bara klimatförändringen utan det är saker vi gör på marken. Till exempel om vi intensifierar jordbruket, får mer avkastning per kvadratmeter eller om vi ökar arealen. Eller om vi bevattnar mer, vi ger mer vatten, då ökar man den här transpirationen.
Before human impact, the amount of water in the cycle was fairly constant. But when we started pumping up groundwater, restraining natural water flows, and draining our lands with no decelerating environments, we also started releasing more water into the atmosphere. Is our water consumption a major reason for the climate change we experience today?
The cycle of water is fairly well established in a natural setting. And before we started changing the climate, generally there were ups and downs in the time that we have come to evolve in. We had the groundwater, we had the snowpacks, we had the ice sheets, and roughly the same amount of water vapor. But as soon as we started changing the carbon dioxide in the atmosphere and then the heating of the system, then that starts to change the amount of water that's communicated from the land to the atmosphere.
Up to now, we've been so focused exclusively almost on the CO2 concentration in the atmosphere that has obviously gone up abnormally. You know, we have assumed that the CO2 rise, because it is a greenhouse gas, has caused the planet to heat up. And certainly that is a key contributing factor. But a far, far bigger factor has been the changes we've been making to the Earth's hydrology.
Not only do we release previously reserved water that increases the amount of water vapor in the atmosphere, but we also contribute to global warming by large-scale monocultivation and growing urbanization. We create islands of heat that repulse clouds and rainfall.
If we have a green vegetated landscape with transpiration cooling, the soils under that landscape rarely get above 20 degrees centigrade, even in tropical regions. Conversely, where we have bare, exposed soil, subject to the incident solar radiation, especially soil that hasn't got water, that soil or asphalt or concrete or that surface can often heat up to 60 degrees centigrade or above, which means that profoundly more infrared heat is re-radiated from hot surfaces compared to cold surfaces.
The monocultures and industrial farming do bring along this phenomena of heat island, because from one day to another, a large area is harvested, and from one day to another, you just switched on, in a snap of a finger, a nuclear power plant that is radiating upwards. So this is how the agriculture and the industrial form of agriculture deforms the weather.
En varm atmosfär kan innehålla mer vatten rent generellt än en kall atmosfär. Och därför så kan vi med ganska stor säkerhet säga att när det gäller till exempel orkaner och den enorma mängd vatten som faller ur dem i form av regn, att det kommer att öka, intensiteten kommer att öka.
We water the atmosphere with fresh water, and with rising temperatures, the hydrological cycle is affected. It's difficult to observe, but in balance contributes to weather processes that affect every part of the planet.
It is dangerous hydrological climate extremes that are going to be impacting, intensifying, and really threatening a whole lot of different ecological and human values. These are hurricanes, these are storms, floods, aridification, droughts, wildfires. And it's these hydrological extremes that kill human beings.
Så klimatets påverkan på vatten, det är både direkt, det vill säga översvämningar, torka, den typen av katastrofer vi ser, men också väldigt långsiktigt. Och det kommer ju i grunden kanske förändra förutsättningarna för väldigt många samhällen på jorden. Är det så att vi är på väg i en situation där det vi kallar extremt idag är det normala om 50 år? Och hur kommer vi då kunna hantera det?
Extreme will become the norm. Don't we already see it today? That environments change for the worse for all living beings. What will our existence look like in the future? It seems uncertain with a changing worldview.
We can do okay when we get droughts and we get wet periods and it's minor. But if it comes 4, 5, 6 years of intense drought, or as in the Colorado River Basin now, we're in 18 years of drought. We have 40 million people in the state of California that are very strongly dependent on that water resource. Where are they going to go if it goes too dry? People don't survive those, they have to move. Civilizations don't survive those.
Lack of fresh water is a reality in many parts of the world, but that is far away, not here. Water is also consumed through direct consumption and as a commodity in our trading systems. It is a virtual, invisible water that hides primarily in products linked to cultivation and agriculture.
Som det ser ut idag så importeras ju väldigt mycket, framförallt från områden där vatten faktiskt är en bristvara. Och det innebär att väldigt mycket vatten flödar idag från de torra områdena på jorden till områden där det faktiskt egentligen finns mycket vattenresurser.
Så även fast man tenderar att se vattenresursen som lokal så påverkar vi varandra över hela världen genom hur vi handlar med olika varor. För vatten finns i allting.
Everything contains water, from textiles to cut flowers. Our lifestyles are costly, and we exhaust water-stressed nations' access and right to safe, clean water. But it's not only about products. Half of the food we consume is imported.
Någonstans kring 30-40% av alla livsmedel kommer aldrig till oss människor, egentligen till nytta för oss människor. Det förstörs i många delar av världen på grund av att man har dåliga lagringsutrymmen efter skörd och så vidare. Eller slängs. Det här motsvarar kanske i princip hela USAs produktion av livsmedel som bara slängs. Och det vi slänger i det här fallet, det är ju vatten också på många sätt.
We consume large volumes of water via overproduction and discarded food. Things which not only unnecessarily waste resources, but also generate pollution.
Our water reflects our behavior because sooner or later everything we do or use or have ends up in the water.
The chemical footprint that we are finding in rivers and lakes is definitely a reflection of how human society interacts with waters. When we are taking samples near a city, it's more dominated by detergents. In an agricultural area, it's more dominated by pesticides. If you take it near a mining area, you have a lot of heavy metals in there. So we can clearly see that human activities are driving the chemical footprint in a river or a lake.
Of the agricultural use of water here in our state of Kansas, the majority would be for watering crops. And one of the concerns as water filters through the soil and makes it all the way down to where the aquifer is water quality. And the one big concern we have is leaching of nitrogen fertilizer.
In this county we have a lot of livestock, so we have a problem with far too much manure, and we see that in our groundwater and also in the water in the ditches and in the canals. So I think nitrate in the groundwater is also a problem for biodiversity in the soil.
The nitrogen leaches down into the aquifer, which contaminates it for drinking, and it isn't just irrigation water that can do that. One of the big sources is runoff from feedlots. Kansas is the largest meat packing state in the United States, and there are areas around feedlots where the drinking water is too contaminated to drink.
It's not just the fertilizers from the meat industry and conventional agriculture that affect water resources negatively and pollute groundwater. The water that naturally gives us minerals and nutrition also gives us completely different substances.
Vattnet är ett väldigt bra lösningsmedel, så det löser upp på vägen och tar med sig föroreningar och sen för det med sig det till vattendraget och fyller på. Det är alla typer av föroreningar som befinner sig i olika delar av vattensystemet. Men det kostar mycket i energi och pengar och ja, frågan är om hur mycket kan vi rena. Jag ser just föroreningarna som ett stort problem och tror att det finns mycket mörkertal, för vi mäter ju inte överallt och vet inte hur det ser ut överallt.
Water quality issues are very local. Because of the nature of the groundwater, it moves in feet per year rather than miles per year. So fortunately, most problems are local and are contained, so that they can be cleaned up some by pumping and diluting. There's really not much we can do to eliminate them, but it's been said the solution to pollution is dilution. If you've got a problem, you can't make the chemical go away, but you can thin it out and spread it over a larger area. That's really the only thing we can do.
We dilute the chemicals in the belief that the consequences will be smaller. But despite our efforts to minimize risks, the efforts of our usage of chemicals are extensive and already noticeable.
We have chemicals that affect pollination. We have chemicals that lead to the feminization of fish populations. We have chemicals that are killing microbes. So it's a huge, broad spectrum that contains everything from heavy metals to pesticides to surfactants to cosmetic products to perfumes, etc., etc.
We are talking about tens of thousands of man-made chemicals that affect nature. A lot of the poison we use on a daily basis passes through treatment plants into our seas, lakes, and water systems.
The drugs that are in the surface water are painkillers, blood pressure medicines, diabetes, anti-epilepticals, all sorts of medicines we use daily. Antibiotics. And, well, they have all different effects on the ecosystems in the water.
Tons of pharmaceuticals are found in our waters, and new chemicals affect us and the ecosystems every day. It's a cocktail of substances that can react to each other and enhance each other, and we know very little about these reactions and their effects.
The cocktail effect simply describes the consequences of an exposure to a complex chemical mixture. And the joint toxicity, the joint risk of that cocktail is usually far higher than that of each and every individual compound. There is no unpolluted site anymore. There is no unpolluted ecosystem anymore. So what we are really experiencing is what we call a blanket of pollution that is basically everywhere.
Our naive relationship to chemicals and chemically manufactured products is unsustainable. This makes large volumes of the available water on Earth useless. And in addition, we have plastic.
Det finns plast i dricksvattnet. Det finns plast i våran kranvatten. Det finns ännu mer plast i flaskvatten. Så vi dricker plast. På varje kvadratmeter yta i en inomhusmiljö så ramlar det ner fler än 300 mikroplastpartiklar varje dag. Så bara genom att ställa ett glas vatten på ett bord så kommer man att få exponeras för mikroplaster. Vi vet att vi exponeras genom luften, genom vattnet, genom maten. Men effekten är inte studerad i människan. Vi har börjat kunna förstå hur mikroplaster kan påverka djur och organismer genom laboratorieundersökningar. Men vi har ingen bra samlad svar på effekten.
Plastic is everywhere and in places where people often meet. Artificial turf, small plastic fragments, and granules make their way down the sewage systems. There's also the possibility that microparticles attract and collect chemicals.
Man tror att plast kan vara en sån partikel som beter sig på det viset i miljön. Så då kan man säga att mikroplasten har varit som en svamp som koncentrerat upp kemikalier. Och då tror man att plasten som äts av, säg, en fisk skulle kunna vara som en trojansk häst där kemikalierna kan röra sig från miljön in i fisken. Och de allra minsta partiklarna kan korsa biologiska barriärer som kan ta sig från tarmen till blodet och från blodet till hjärnan.
Microplastics attract chemicals and move them to important organs. How will this affect the ecosystems? How will this affect us?
Vi använder plast till väldigt många olika saker i samhället, så vi har det överallt.
What happened? The water cycle is everywhere. Cleaning, filtering, drinking water, rainfall, climate balance. But it's been downgraded to a consumable and a transport system for pollution. The planet's bloodstream is draining. And surely, this reflects us as humans and our short and intense time on Earth.
Over the last 200 years, that's the period that humans have really come to have an enormous influence on the Earth system. And industrialization itself is not all bad. It's just how we capture what we're doing and understand how we're influencing ourselves, influencing our ecosystem, influencing our water supply.
The overuse of water is a tricky point everywhere in the world. So it's very important to manage water like a sustainable resource.
Bottled water is generally a water-consuming activity, but there are exceptions. The Belgian company Spa Monopole works sustainably by adjusting its output according to groundwater levels and by protecting nature. They know that the key to a smooth and safe water supply is biodiversity.
Biodiversity is like a pyramid. At the top of the pyramid, this is a place for human being. And if biodiversity disappears, human beings disappear too. So it's very important to protect the biodiversity. And also there is a big connection with water. Clearly all this area play a role for the good water capture, but also for the good water infiltration, like the peat moss. And this area is also important to reduce the global warming. It's a wet and peaty area, and this kind of area it's able to catch or to capture 10 times more CO2 greenhouse gas than another soil. It's very important to preserve this place to catch and to reduce the global warming.
We need more people who understand the relationship between water and biodiversity, water and climate, water and all other beings. To administer this relationship seems climate-friendly. Maybe the opportunities are already found in nature.
Det är inom jordbruk och skogsbruk som vi idag kan hitta de stora och viktigaste lösningarna när det gäller just klimatfrågan. Vi vet att skogen har en fantastisk förmåga att binda kol genom fotosyntesen. Och här gäller det då att utveckla ett skogsbruk som helt enkelt blir en så bra och stark kolsänka som möjligt. Men även inom jordbruket finns det ju fantastiskt stora möjligheter att utveckla teknik som helt enkelt binder kol ner i marken.
We have to take carbon out of the air that was basically put there from our degradation of our landscape and put that back into our soils to rebuild the sponge so we can rebuild the hydrology. 2 to 3% carbon added into the soil can create these structural regeneration effects, add voids, surfaces into that soil matrix and really rebuild healthy soils.
Through photosynthesis, carbon can be bound in the soil, letting nature transform carbon dioxide into a rich soil with microorganisms that make the soil healthy and water retaining. This way, the climate, the water balance, and our arable land will be positively affected.
In the spring, when the photosynthesis turns on, you will see significant drop in terms of the amount of carbon dioxide in the atmosphere, which goes down as the photosynthesis progresses through the summer. And then when we hit the fall and everything is harvested, again you will see a significant increase in terms of the concentration of the carbon dioxide. So this shows the magnitude of impact that the photosynthesis has on the amount of carbon dioxide in the atmosphere.
Soils are also fundamental because it's the only point of agency, the only point of influence we humans have on the Earth's climate, hydrology, and our future. You see, we can't change the oceans, we can't really change the ice caps, we can't really change the atmosphere, we can to some extent, but the real point of agency is the sponge.
There is clearly an overconsumption of the water resources on the planet. A consumption that affects the climate, the ecosystems, and everyone on Earth. We have to end the idea that fresh water is infinite. And to understand the value of the hydrological cycle, as well as the solutions that nature already has developed for the climate.
We are not using the systems that nature provides us, the lesson that nature provides us, and we think we are above nature. And we have lived the last century with delusions that we can fix things technologically. But I think the reality is coming that there are limits, there is an imperative for regeneration, and hopefully we will have the wisdom to now say, hey, let us work with nature. Let us get our boot off her throat and let her breathe and let her help her to actually regenerate these biosystems.
We should be more aware of the fact that our groundwater is a treasure and use it with respect as you treat a treasure. It's a miracle. Somehow it's a miracle. But we are so used to it that we can't see the miracle in it anymore.
Det som vi måste göra nu är som ett samhälle hålla reda ut hur vi använder våra vattenresurser. så att vi inte använder för mycket och förorenar för mycket och slår undan grunden för vår egen existens.
So we really have it in our hands now to understand how these water supplies are changing, these water fluxes, as well as the interaction with the climate are changing, so that we can sustain the standard of living and the health of the human population.
We are one. Us, the water, and nature. We need to rethink, to stop polluting and draining, and instead retain the water on the continents. Be conscious of carbon storage, and think of cultivation methods that replenish the water in the soil, in the ecosystems, and in the groundwater. We must think of photosynthesis and nature's own climate control. But we must also understand that balance in the water cycle is a fundamental condition for our future.
Clearly, we have messed up the show. We have degraded these lands, the sponges, the in-soil reservoirs, the hydrology, the cooling of the planet. Nature will always be here, however, and nature can and will restore these biosystems. The only question is, will we help her do that, or let her do it by herself after we are gone?